going to take you through just problem solving with questions from the line. And I showed this in the last video as to how I kind of have a process in my head as to how I tackle a question. It mightn't always work, but this is generally my 3 go-to things. And if it's not these, it's probably quite a tricky question, so I'll just give it my best shot. So I'm going to have a look at the question and kind of keep those things in mind. So if they ask me to find the distance between the line 3x minus 4y plus 10 equals 0 and another line 3x minus 4y plus 15 equals 0. Now, some of you might spot very quickly there that these are parallel lines. How do I know that? Well, if you move this around, you will get a slope of 3/4, I think, for both of them, because the x coefficients are the same, the y coefficients are the same. So if you manipulate them around, you will find that they have the same slopes. Okay, they might have different, when you move them around, they might have different values for C, where now if you look at your log tables in this situation, it's saying C is where it cuts the y-axis, or it's the y-intercept. So you might notice that, yeah, they'll have different y-intercepts if I move them around, but they'll have the same slopes, which means that they're parallel. So if I want to sketch this, and they both have a slope of approximately 3/4, we're looking at something like this. If I wanted to sketch it better, I could obviously draw my x and y axis, etc. So if I get very stuck, I might try that. But it's always good to give yourself a diagram. It's hard for your brain to just picture things all the time. So give it a concrete diagram, and the more you get stuck, maybe the more accurate your diagram needs to be, or if you have time, obviously. So my first thing is, do they mention a formula? Well, I'm going to go down through my formula and notice, yeah, they did mention distance. So length is another word for distance. Okay, slope, no. Midpoint, no. Equation, well, they gave me the equation of the lines. They don't care. It seemed they didn't even mention the area of a triangle. They didn't talk about dividing a line segment. Here's another distance formula. So there's a second one, and here is the angle between 2 lines, which again they didn't mention. So I'm looking at these two kind of here. I'm trying to narrow it down. This is my problem solving. This is how I tackle problem solving. I look, did they mention anything? And if they did, is there a formula? So now we have 2 formulas, and I need to have a think about this. So if I can find any point on this line here, and perhaps I find another point, I'm able to find some point on this line here. They've asked me for the distance between the 2 lines. Now, I mean, I could get any distance, like I could travel for ages. So they're not just looking for the distance, they're looking for the shortest distance. And the shortest distance is the perpendicular distance. So if I'm able to find that point and that point, like 2 random points on each of my lines, I mean, maybe I find out where this one cuts the x-axis and I find out where this one cuts the x-axis, or maybe I find out where this one cuts the y-axis and this one cuts the y-axis, and so on. But if I'm able to do that, then these are probably going to be 2 random points, and they're not going to be the shortest distance. So to me, it doesn't make sense to use the junior cert method, because the junior cert method isn't going to get me the shortest distance unless I'm very, very lucky. It could happen, but it doesn't seem like it's likely to happen. So then I'm left with the perpendicular distance formula. Well, that sounds good. It's the shortest distance. And if I look here, it says if you want to use the perpendicular distance formula, you need a point. Okay, I bet I can find a point on one of my lines. So I'm going to pick this line here. 3x minus 4y plus 10 equals 0. And I might try and find a point on that one. And what else do I need? Not only a point, but I also need a line. Now the line has to be in this format. So is the line that we want, that we have here, in this format? Yes, it is. So that looks good. I just need to find a point on this line. Now, find any point you want, because you're just going to end up getting the perpendicular distance from a point on this line to this line. Once I use that formula, it is the perpendicular distance from a point to a line. So how do I find out maybe where this one cuts the maybe where this one cuts the y-axis? Okay, so maybe it cuts the y-axis, I let x equal to 0. So if I let x equal to 0, and then I end up at minus 4y equals minus 10, which means y equals 10 over 4 minus 10 over 4, which, you know, gives me 10 over 4, which simplifies to give me y equals over 2 or 2.5. So that means that's a point on my line. And I'm going to get the perpendicular distance from that point to this line here. So I get my perpendicular distance formula, and you know, that's A, that's B, and that's C. So we have A times x1 plus B times y1 plus C all over the square root of A squared plus B squared. And if you throw that into your calculator, you'll find out that they are 1 unit apart from each other.